Geometry of 2D shapes, quadrilaterals, grade 8. Do you see all the quadrilaterals that were used to make this picture on the left side? So Xing loves solving puzzles, but she also knows that in order to solve problems in quadrilaterals, she must know all the properties of the quadrilaterals. Thanks, Xing. So we're still in flat land and we're looking at flat shapes. The triangle thought she was special, but here comes along the quadrilateral. And the quadrilateral thinks he's more special. He's got two diagonals. What is a diagonal? It's a line that connects the two opposite vertices. Let us meet the quadrilateral family. First of all, look how beautiful this is. So in this lesson, we want to know what is a quadrilateral, how do we classify quadrilaterals, what are the properties of all the quadrilaterals, and how do we use that to solve problems in quadrilaterals. What is a quadrilateral? Well, it's a polygon with 4 sides, 4 angles, and 4 vertices. Remember, in a triangle, the sum of the interior angles is 180 degrees. Now, the sum of the interior angles is 360 degrees. How do we classify quadrilaterals? This is a kite. Let's look at the sides. 2 pairs of adjacent sides are equal. This side is adjacent to that side. The 2 sides meet at that vertex and they lie next to each other. The same with the blue sides. Do you see that they are equal? What about the interior angles? Only 1 pair of opposite angles are equal. See the red angles? And the diagonals, this diagonal, the long one, cuts the shorter one into 2 exactly equal lengths. So we say the one diagonal bisects the other diagonal. At right angles, notice the 90-degree angles. So this diagonal is perpendicular to that diagonal. The trapezium, poor old trapezium. There's 1 pair of opposite sides that are parallel, and we use arrows to show that. And then we can say the interior angles, the sum of the interior angles is 360 degrees. But since this is a trapezium where there are no equal sides, the diagonals do not bisect each other. The parallelogram. Let's look at the sides. 2 pairs of opposite sides are parallel and equal in length. The interior angles, the opposite angles are equal. And the diagonals bisect each other. Let's look closely. We use arrows to show that this pair of sides is parallel, and we use 1 arrow to show that this pair is parallel. We use little lines to show that the sides are equal. And then angle A is equal to the other angle because they are opposite each other. The diagonals, this diagonal, cuts the other diagonal in 2. They bisect each other. So in the parallelogram, we can use this notation. Line AB is parallel to line CD. This symbol means parallel. Line AD is parallel to line BC. Line AB is equal to line CD. We use a small line to show that. Line AD is equal to line BC. We now use 2 small lines to show that. And angle A is equal to angle C, and angle B is equal to angle D. Make sure you understand the notation that is used in the diagram as well as on the side here. The rhombus. Let's look at the sides. two pairs of opposite sides are parallel and all the sides are equal. The interior angles, opposite angles, are equal. The diagonals bisect each other. So this diagonal cuts this one in half and this one cuts this one in half. The rectangle. The sides, two pairs of opposite sides are parallel and the opposite sides are equal. The interior angles. Yes, the opposite angles are equal, but they are also all 90 degrees. And the diagonals bisect each other and are of the same length. So there are your parallel lines and your equal lines. The diagonals bisect each other and they are exactly the same length. The square. Opposite sides are parallel and all the sides are equal in length. The interior angles, yes, the opposite angles are equal, but all the angles are 90 degrees. And the diagonals bisect each other and are equal in length. Check it out. The best way to study and to know these properties is to draw the diagram while teaching somebody else. Happy learning!